All right, setting up now. All right, we should be good to go. So welcome, Mickey, and we turn the time over to you.
All right. Hi, everybody. Let me share out my screen. Wait, I can't share my screen because you're sharing your screen.
I will stop sharing.
Now let me try to share out my screen. Find the right screen. Okay, there we go. So, hey, everybody. I am Mickey Gousset. I am a DevOps architect on the GitHub Fast Track team, as was mentioned. And I'm excited to be able to come back and give you a slightly more advanced look into GitHub Actions. So I'm trying to keep this to a little bit less than an hour, so I might not get to all the content, which is okay. So if you go to youtube.com/Mickey Gousset, you'll find all the videos that I do out there around GitHub. Plus, you're going to have my contact information that I'll give you at the end of the slide, where you're welcome to email me. I'll be happy to hop on a call, answer questions, try to help you out if you got some questions. I love the community. I love giving back to the community. Now, two quick things about me. First off, I sometimes talk really fast, especially when I'm excited about a topic like I am with GitHub Actions. So I may start talking a little fast. If I talk too fast, tell me and I'll try to slow down. The other thing is I am a good Southern boy, so they're from Mississippi. So sometimes when I get excited, I also drop into a heavy Southern accent. So if I do that, and I say something you don't understand, feel free to tell me. Now, being a good Southern boy, I have to ask you, and for those of you that came to the session last time, you know the answer, but for those of you that don't, I have to ask you a quick question, which is, let me get over here where I can actually move my slides. There we go. Do you know what Tupelo, Mississippi is world famous for? Because I am from Tupelo, Mississippi. We are a small 30,000 person town in Northeast Mississippi, and we get thousands of people a year that come to my town, probably half of which come from Europe. Kelly says he knows. What is it, Kelly?
Elvis.
That is correct. We are the birthplace of Elvis Presley. So Elvis Presley was born in a two-room, not a two-bedroom, but a two-room house, a bedroom and a kitchen. So they call it a shotgun shack because you shoot a shotgun through the front door, the bullets will come out the back door and not hit anything because there's no dividing wall. It's just one big room. So people come, they tour his house, they go to the hardware store downtown where he bought his first guitar at age 11, still a hardware store, still owned by the same family that sold him that guitar. And then they go up to Memphis, Tennessee to see Graceland, which is where he lived when he got famous. Now, I love Tupelo and I can talk about Tupelo, but we're here to talk about GitHub Actions. So we build this as a slightly more, as a more advanced talk on GitHub Actions, in that it's going to actually build off of the previous talk that I gave. As mentioned, the previous talk that I gave is on the user group YouTube channel, so feel free to go check that out as well. But because we're making that assumption, I'm not going to go into as much deep detail on an introduction to Actions, exactly all the detailed specifics I normally would if I was introducing this for the first time. Instead, I'm going to give a brief overview, and then we're going to jump directly into looking at using Actions in a real world example, but making use of things like reusable workflows and building our own custom actions so that we can write some code once and reuse it multiple times. And then I'm hoping, time permitting, we'll even get around to some of to talk about caching, which can make your workflows run faster, as well as a new feature we've just got out there called restricted workflows, which are workflows that you can force the developers have to use in their repositories. But I also want to point out that we have a mobile app. Feel free to go grab the mobile app if you want to. Also, feel free to navigate to this repo, which is basically just, if you go to github.com/MickeyGousset.org, then there's a repo called GitHub Actions Presentation. It is a public repo. All of my talks, all of my demos, everything that I'm showing you tonight in there for free, including the slide deck. Feel free to use it. Use whatever you want. Now, real quick, in case you don't know, GitHub Actions is GitHub's workflow automation system. And I call it workflow automation system because it does more than just CI/CD. It does CI/CD. We're the #1 CI/CD system on GitHub now, on github.com now. But it does more than that, because you can use it to trigger off of any event that happens inside of GitHub. And we'll actually be doing that in this demo. So I can trigger off of creating an issue. I can trigger off of creating a pull request. Otherwise, other quick things you need to know: when you're going to be building workflows, which are going to have jobs, and steps in them, and those workflows need to run somewhere. We have hosted runners you can use. You have self-hosted runners you can install yourself. We provide Linux, Mac OS, and Windows hosted runners if you want to use our hosted runners. And we now have what's called our large hosted runners, which will allow you to have beefier runner machines, like with 4 cores or 8 cores, if you need them for running your workflows. Quick overview of terminology. This is normally where I would talk a little bit slower and go into the details, but we're going to hit it pretty quick. You have events that are going to trigger your workflows to run. Now, your workflow is a YAML file. It's a YAML file in your repository. So love it or hate it, it's a YAML file. You get to deal with white space. And so if you've never dealt with YAML, white space is important. So you have to actually make sure you've got things indented correctly. Now, in your YAML file, you can have one or more jobs that are going to run. You can have one job, you can have multiple jobs. Then in each job has one or more steps, which are the actual things that you want to do. And a step could be a script you've written in, say, Bash or PowerShell. It could be an action from the GitHub Marketplace. There's a variety of, those. So it's basically that singular task that you want to accomplish at that step. Now, a job is what runs on a runner. So a runner will pick up a job, execute all the steps from that job, and return the results. If you're using hosted runners, those runners are ephemeral, which means that it spins up the runner, it does what it runs the job, and then it throws it away. If you're using self-hosted runners, by default, those aren't ephemeral. You're going to have to build your own system to have ephemeral runners, but we do have a project that was a community project that we're now that GitHub is now taking over, called Action Runner Controller, which can let you spin up a Kubernetes system and be able to spin up and tear down containers, pods in your Kubernetes system. But you've got an event that's going to trigger a workflow to run. It's going to have one or more jobs in it with one or more steps. That stuff's going to run on the runner. A couple of other areas to be aware of: we do have secrets, because you do have to have a way to just specify things like passwords and such. And if you're using something like Azure Key Vault, you have the ability, you can continue to use that. But if you're not, we do have a secret store that you can use inside of GitHub. And finally, we have this concept of environments, which we're going to be using in most of the demos, which are, the idea is, think of these as like objects or folders. Like I have a dev environment, and I can target a job at the dev environment. And when I target the job at the dev environment that I've created inside of GitHub, I can have things like gates that have to be true before that job will run. I can have secrets that are only available if you're targeting that particular environment. So they allow you to have some control over when the job will run. For example, maybe before you deploy to QA or you deploy to prod, you want a manual approval to happen. I mentioned, so quick summary, you've got events that trigger workflows that are going to reference actions. And as I mentioned, there is a marketplace out there. So we've got a marketplace out there. It's actually, I think, over 17,000 actions out there that have been built by GitHub, verified partners, or verified creators, as well as the community. And in fact, I've got an action out there, which I'm hoping to get to show you, which is, will tell you a dad joke, because I figured everybody needs the ability to tell a dad joke in their workflows. So hopefully we'll get to that point. But that's enough. That's enough to get us started. So I'm going to show you a super simple demo, and then we're going to jump into something a little more complex. And what that little more complex is going to be is not the exact demo I did last time. Now, the demo I did last time, when I wrapped up the session last time, was we had a .NET Core MVC app. And when we create a pull request, I want the code to build and test to verify that it's clean before I can push to main. So I wanted to make sure I enforce that. And then when I did merge the pull request to main, I wanted to build the application, and then I wanted to deploy it to dev and QA at the same time, and then have a manual approval for deploying to prod. So that was the demo that you'll see in the previous video. We're going to actually do the exact same kind of thing, but we're going to make it a little bit fancier. And by making it a little bit fancier, we're going to do things such as, we still got the .NET Core MVC app. On the pull request, we still want to build and test the code. But this time, we're going to take all of that code that we previously had and make it a custom action. And by making it a custom action, I'll be able to reuse that code in multiple other places. Then, on the push to main, rather than do our deployment directly on that push to main, what we're going to do is build the application and then create a draft release in the repository. And so GitHub repositories have this concept of a release object. So we're going to create a draft release. And then when we publish that release, when we move it from draft to published, we're going to use a reusable workflow to be able to deploy to multiple environments. And a reusable workflow is similar to a custom action, but whereas a custom action is just one or two steps, a reusable workflow is an entire job. It's an entire actual workflow file. And it's another way to promote code reuse. Now, we get through all that, then we'll look at some of the other fun stuff, but this is the core of what I really wanted to make sure I showed you tonight, because it shows you, using custom actions, reusable workflows, releases, and dives into everything in a little more detail. So let's go find the appropriate web browser, and here we go. So, as I mentioned, this is the Mickey Gousset org, github.com, Mickey Gousset org, GitHub Actions presentation and repository, and all of my code is in this repository, including the demos and descriptions of how to even do the demos. Now, first thing I want to do is show you the most basic workflow there is. So whenever you create a GitHub Actions workflow, it has to exist in the .github workflows folder of your repository. Now, the most basic workflow you can have would be this right here. And this is the most basic workflow you can have. And it has, it's a YAML file. It's got a display name called basic workflow. It's got a trigger. So a workflow can have one or more triggers. Those are the events that are going to make the workflow execute. For this one, I have one trigger called workflow_dispatch, and that is the event that specifies that I want to run this manually. So all I'm doing here is running this manually. Now, when I do have a workflow that I run manually, I can provide inputs. So I'm asking you to enter your name. I'm asking you to select your favorite city. You can see I've made it of type choice, and I'm giving you some options. And then I'm giving you a checkbox to say, favorite color blue. Is that, do you want to, is that true or false? So after you start this and you enter in those parameters, you have a job section. And this is where you can have one job or multiple jobs in your workflow. If you have multiple jobs, by default, they run in parallel unless you make them run in a certain order. But I've got one job and I called it greet. Now, this job has to run somewhere. And by specifying Ubuntu latest, I'm saying I want it to run on a Linux machine that's in our hosted environment, meaning that it's a hosted runner GitHub manages for you. So it has all the software, most of the software you need to do builds. And we take care of spinning it up and tearing it down. And then finally, I told you that a job has one or more steps. And in this case, we've only got one step. We called it send greeting. And that one step is just a small script that I've written. By default, if you're using a Linux machine, you're in a bash shell. If you're using a Windows machine, you're in a PowerShell shell. Since I'm in a bash shell, I've written a bash script, which is just doing an echo out. And all I'm doing is echoing out the inputs. So for example, I say hello, and to get to the input, I say $ curly brace. This is how you access variables. And I go to the GitHub context object. When you kick off a workflow has, there is a GitHub context object that goes with it that has all the information about the workflow, who kicked it off, what repository it came from. And in this case, it also contains the inputs that you provided. So I basically say, okay, GitHub. So I go GitHub, go to the event that triggered this, go to the input that was entered, and give me the name. And I do the same thing with city, and I do the same thing with favorite color blue. So to run this, I go to the Actions tab, and I can select my basic workflow. And you can see I have a Run Workflow button. I can select that Run Workflow button. I could run this workflow against the main branch or one of my other branches if I wanted to. And I'll take the defaults, and I will click Run. Now, this is going to spin up a workflow that's going to run super fast. But here we are in the workflow log. Okay, and this is going to show me that I've got one job. It's currently already finished. And I can go into that job. And if you're used to using, say, Azure pipelines, this is going to look very similar. It's the same kind of live feed that comes back as each step runs. But here's my send greeting step where I wrote out, hello world, your favorite city is Tupelo, and your favorite color is not blue. So in a workflow file, you have the event or events that are going to kick it off. You have the jobs, you have the where those jobs are going to run, and then you have the steps that make up the job. So there's your crash course intro, your intro crash course, let's put it that way. So given that, let's actually go back to how we're wanting to this actual deployment of this .NET Core MVC app and how we're going to do it a little bit fancier with custom actions and reusable workflows, and explain what all is going on. Now,
so
first,
Mickey, before you jump into that, we do have a question in the chat. Caleb's wondering, does GitHub Actions support something equivalent to Azure DevOps' service connections?
GitHub Actions supports something equivalent to Azure DevOps service connections. Let's see. So there's nothing that you specify in, say, in the GitHub interface here that where you would create a service connection similar to how you would in Azure DevOps. And instead, that's probably instead you'd be either potentially using a GitHub app to request access to something, or you're going to add that code into your workflow itself. But there's nothing specific inside of GitHub where you're going to specify that service connection. For example, to log into Azure, in this case, we have a couple of different options. You could either create a service principal and put that in the put the secrets around that in a secret inside of GitHub and use that. Or, as I'm going to do in this example, we're actually going to use OpenID Connect to be able to connect to Azure, which is a slightly more secure way of doing things.
Okay, thanks.
Okay, so let's go back over here, and I need to enable a couple of workflows to make all this work. So you can enable and disable workflows if you want to. So in this case, I need to, and don't worry, I'm going to show these all to you, but I just need to enable them. The reason I had them disabled was so that they wouldn't run while I was doing other things and confuse the matter. Also, I'd like to call your attention to the lamp in the background of my video, which is a nice, I guess, yellow color right now. Just wanted to point that out. It's a nice yellow color. All right. So here's the deal. I want to make sure, I want to enforce that Gary can't push to main. All right, I want to enforce that he makes a pull request in order to, and therefore, so that we can make sure the code builds and tests before it gets pushed to main. So what I'm going to do is I'm going to create a branch protection rule. So if I come in here to my branch protection rule, I specify the pattern I want to match, which in this case I want it to match against my main branch. And I have a lot of different rules that I could specify, but all I'm going to specify is that you need to have a pull request before you merge. And I'm going to specify that all status checks have to pass before you merge. Now, one of the things I can do with status checks is I can say a status check is a particular job. So this is a job in a workflow that has to run and pass, in this case, build the code and test the code before I can actually merge the code change. So let's go make a code change. So we'll come out here to our source. We'll go to my web app. We'll go to pages, go to shared, go to the layout. And just to keep it simple, all we're going to do is add a new menu item. And we'll just add a quick new menu. Oh, got to put it in edit mode first. Again, I'm editing through the browser here. You could edit through, I could pull this down and do it through VS Code, but I just find this a little bit easier from a demo perspective. But we're going to call this slc.net rocks. I'm going to commit my change, and I'm going to create a new branch for this. And we'll call this just the SLC branch. Or we'll, commit method will be SLC. And my branch will be Mickey Gousset /SLC. And I'm going to propose a change request. So that's the only change I want to make. Now, before I do that, I just want to double check, because I actually did not turn on my branch protection rule because I did not click the save button. Because otherwise it wouldn't have allowed, it wouldn't have given me the option to push to main. So when you modify your branch protection rules, scroll all the way to the bottom and click the big green Save Changes button. In GitHub, you're going to find areas where you click something and it automatically saves it, and other areas where you have to click a save button. So now that we've got that in place, let's create this pull request. Now, what we're going to see when we create this pull request is, oh, well, that's all. Oh, there it goes. So here's my build and test of the PR that's going to run. So if we let that run for just a second, what we're going to notice is, it didn't happen as fast as I wanted. That's fine. So what does that code actually look like that's doing this build and test on the pull request? This is running because I set that check. Oh, crap. Oh, no, look, see my the build's running. So the light's flashing. So the build's running. So that's good. So, oh, but now the light went red. So something happened with the build. So let's go check that out, and then I'll explain what this workflow is doing. So if I come in here and look, the build failed. And if I go in, or something failed. If I come in here and look at the details, and I go to my summary page here. Well, if I look at the details here, I can tell that this, whatever this build, test, publish, upload code job is, failed. But if I go to my summary page and I scroll down, then I can actually see that I had a couple of tests that failed. So I had 2 tests that actually failed. So I'm going to do what every good developer does when the tests are failing, right? Switch over to
Disable
my
the
branch.
tests.
Exactly. See, somebody read my mind. So we'll go in there, we'll go to the tests, we'll go to the unit test itself, and we'll just, edit that. And we'll comment those out. And then we'll save those changes. And because I'm making this change to a branch with an open pull request, then the workflow is going to kick off again automatically. So now it's going to run again, and we'll see if that passes or not. So while that's doing its job, let's go see what's actually happening behind the scenes to make this work. So remember, all of your workflow files have to exist in that .github workflows folder. And I have, all right, there we go. This is the workflow that is kicking off when we run that. You can see the build's running, my light's flashing. This is the workflow that runs when we create a PR. So my event that triggers this is a pull request against the main branch. There's lots of different options here. You could say you want to target all branches, certain branches, ignore certain branches. But in this case, I'm running off against the main branch. And I've got one job, which is I've called build test branch. Looks like my build was successful because my lights turned green. And the name of that job is, build and test of PR using composite action. Great. And so it's going to run on Ubuntu latest. And then I have my step that's going to run. And this is basically what's messing with my light. I got a LIFX bulb in that light. And so this is just doing a curl that makes it flash. And then I've got another step that says whether it passed or not. But this is doing all the hard work. What I had previously in the demo is about 80 lines of code here. So now what I have is one section of code that does a build and a test and a publish and even uploads the code for me. So I am calling a custom action I've created over here in this repo called GitHub Actions Presentation Composite Action. And then I have to pass in some parameters to make this work. So I'm passing in the location of my solution file, what type of build I want to do, the location of my proj file, and what I want to call the published files. Then I have two steps here. One that checks if the previous step was, if everything previous was successful, and if it was, then it changes the light bulb to green. The other that checks to see if any of the previous steps were failures, and if they were, it changes the light bulb to red. But this is the special sauce. This is a composite action. And the reason I did this is because I was finding that I was using the same code on my pull request that I was using on my push to main to do the build and to run the tests. So rather than define the same code twice, I created that code in one spot, and that's where I'm accessing it from. Now, when you're accessing an action that's in another repository, then you're going to say on your uses command, you're going to say the organization where that action is, the repository where that action is, and then you have to specify a version. So I could either do an at release version like V1, V2. I can target a branch, which is great for development. Or if I want to be really secure, I can target a commit SHA. So I could say at and a commit SHA and target the exact commit version of the action I want to use. That is the most secure way to do it. In this case, since I'm just doing development, I just targeted main. Now, one of the nice things is if I want to show you this code, all I do is grab its name and come over here and go to github.com and paste that in, because that's the organization and that's the action. Now, any action from the marketplace that you use has to be in a public repo. That way you can look at the code. So this is one of three ways to build a custom action. It's called a composite action. All it is you've taken a series of steps and turned it into a single action. The other ways to build custom actions are using JavaScript, which is the most difficult way, but the most powerful way. I say most difficult because you've got no JavaScript. Or you can create an action using any language you want to, say like using C# or VB even, but you have to do it in a container, and those are really slow. In this case, I'm using just a composite action here. And all you need to make up a composite action is this action.yaml file. That's it. This is everything that makes up my composite action. Now, if I open that, what I see is I have my composite action name. I give it a description. Here's where I specify the inputs. So there's the solution, the config, the CS proj, etc. Line 20 is the special sauce. That is what tells GitHub Actions that this is a composite action as opposed to a JavaScript action, as opposed to a container action. And then after that, I just have steps. I just have I have a bunch of steps here. And again, I did this, I created this composite action because I was duplicating this code in multiple workflow files. So now I could just have it in one spot, and if I have to update it, I update it in one spot. Now, what this action does is, using a checkout action from the actions team, we check out our code. Now, the hosted runners already have .NET Core 6 on them, but if they didn't, then I could run this action to install .NET Core 6. How did I find it? How did I find that action? I went to the marketplace. Went to github.com/marketplace, and I did a search for setup node, and this action came back. Then I just do a .NET restore. I do a .NET build, and then I do a .NET test. Now, for my .NET test, I'm actually outputting the information as JUnit, and I'm doing it into this test results.xml file. And I'm doing that so that I can use an action further on down that's going to actually display the results. So I do a .NET restore, a .NET build, a .NET test. Nothing rocket science there. But now I want to take the test information and display it on the screen. So by default, your tests and such aren't going to display on the workflow file as I showed it to you. You have to add some code to make it display. So I'm doing a couple of things. The first thing I do is I use this test summary action. And what that does is it takes my test result XML file and it creates a pretty markdown file. So instead of displaying ugly test results in XML, it creates a pretty markdown file with the information in it. But then I need to take that markdown file and actually make it show up on my workflow. So to do that, I make use of $GitHub step summary. Essentially, you shove information into that, and at the end of the job, it's going to display at the end of the summary page. So what I'm doing is writing the header test results, echoing out a blank line, and then I'm taking that summary MD file that I created up here previously and catting it into that GitHub step summary. And I'm using an if statement to make sure it always runs, because I want it to always run whether the test pass or the test fail. Finally, the last couple of steps I'm taking here are, I'm actually going to create the artifacts that I want to publish. And the reason I'm doing that is I'm not publishing these artifacts from the pull request, but I want to give them to the developer so the developer could look at them. So I just do a .NET publish to output those objects, and then I added in some code to zip it up the way I wanted it zipped up. And then finally, I'm actually going to upload those actions using an upload artifact action to the workflow itself. So the developer can go to the workflow that ran and they can see what the output code would be and could review that. And so I do that using this upload artifact action. And if we come back out to, and all of that code then condenses into just this. And it's just those 7 lines of code that I have to copy over into any other workflow file to be able to use this build and test. And if I go to my actions and I go to the pull request workflow that ran, we can see that it completed successfully. I've got one artifact. Here's the test results, and here's that pretty markdown. So all my tests pass. And here are the build artifacts. And I can click that, I can download it, I could view those artifacts. So I've got green. So therefore my pull request passed. Let's go back over to my pull request. And let's merge it. Now what happens on a merge is we're going to build the code again, but now we're going to create a, oh, that's awkward. Oh, that's awkward. Let's stop it. Mickey undisabled the wrong one. So let's do this again. Let's disable this workflow. My apologies. Let's enable that workflow. That one's there too. Okay, so let's go make another quick change and solve it so I can show this to you. So we'll go back over here to our main branch, go back over to where we're making a change. In this case, we'll just edit the README file, because that's always a good thing to edit. Add a blank line, commit the change. In this case, we'll call it, please work, I'm embarrassed. And we'll commit it directly to the branch. We'll create a quick pull request. So we'll create a pull request comparing my SLC branch, create the pull request, create that pull request. Now what we've got is we're going to have to run the PR again. And so it's going to come back, my lamp's going to flash, then it's going to turn green, and everything's going to look great. All right. So while that's happening, let me show you the next workflow that's going to happen. When we merge the pull request, we're going to have a push to main that happens.
So we've got one more, we've got another question if this might be a good time for it. The question is, does your uses statement for the composite action choose the desired version via a tag in Git, or are there multiple versions present in the repository in some other way?
So it's doing it. So in that case, so for my composite action, in this case, I was actually using a branch name. However, you can use tags instead, right? So I could have created a V1 tag or a V2 tag, and I could target at V1 or at V2 or at Mickey is awesome if I created a Mickey is awesome tag. The problem with tags is they're not immutable. So I could, if as someone who owns this code, I could move those tags around. So therefore, you might be using what you think is the tag V1, but it's actually not because I moved that tag. That's why tags are not the most secure way to do it. But honestly, right now, they are the default way that most people do it, is they create a tag. And they also create a release at that point off of it as well. Great. All right, my lamp turned green again. So let's go merge that PR and then look at what this thing's actually doing. Now, that is going to kick off. Let me make sure it kicked it off. It did. So that is going to kick off some code that I created to create an actual release. So push to main creates a release. Now, what this does is, well, I could have run it manually, interesting. Or I'm running on a push to the main branch. And again, I have to give it a name, give it a runs on. Here's that same code to build and test the code. Again, now I'm seeing the code reuse because I'm able to use that custom composite action in multiple places. And then I'm just going to use an action from the marketplace called, from soft props, called action GitHub release. And this is going to create a tag and create a draft release for me. So in this case, these are the files that I want to upload. These are the web files that were zipped up in my custom action. I want to create a draft. I want to call it actions, presentations, web app files. I want to generate release notes. And I want to give that, specify the tag name. And in this case, I'm specifying the tag name as the run ID of the workflow dot the run number of the workflow dot the run attempt of the workflow, which gives me a unique number every time. So, you know, I wanted to come up with some way to have a unique tag. That's what I did. And if we come back out and look at that push to main, it worked. And if we come back to our code page and we go to releases, we now have a draft release. So I could build up lots and lots of these draft releases, but when I'm ready to deploy one, like, and this is actually a real world example from a customer. This is what they do. When they push to main, they create a draft release. And then when they're ready to actually deploy it through their process, they edit it. They come in here and change it and make it a published release. So if I come in here and make this a published release, then you can see there's my web app zip. There's my web apps, my files that I want to publish. And if I come back over here to the Actions tab, we're going to see that I'm currently running my publish this, my workflow that's going to publish this to dev and QA, and then also manually approve it to prod. Okay, so what does that workflow look like? So in this case, I'm going to be using a reusable workflow to do this, because my deployment to dev, my deployment to QA, my deployment to prod is the same thing happens every time, just some variables change. The web app I'm deploying to, a couple of other things. So I created a reusable workflow to do this. Could I have created a composite action to do this? Yes. When would you use a composite action versus a reusable workflow? You use a composite action, like my build composite action, if you have other steps that you want to run before it or after it. In this case, controlling my light behind me. Or if you're not going to have anything else, if that's going to be the whole job, you can make it a reusable workflow. And then you've just got the whole job that you've specified. So in this case, I'm triggering on not a PR, not a push, but I'm triggering on a release event of type published, meaning that I have published this release. Now, I am using and I'm publishing to app services in Azure. Now I'm using OIDC in Azure to be able to connect to it, which allows me to not have to deal with any secrets. However, I have to add this permission ID token right. And that's because when you start a GitHub Actions workflow, it runs as what's called the GitHub token object. And by default now, the GitHub token object has read access to your repo. That's it. But you can give it elevated permissions by using this permissions tag, in which case, to be able to use OIDC, I have to add in this ID token right to be able to connect to Azure the way I want to connect to Azure. Now, the other thing I have going on here before we even get to the reusable workflow part is concurrency. So I have this kicked off right now, deploying to dev. What if Gary also pushed to main or published a release and his started running at the same time as mine? By default, they'd be running at the same time and they might clobber each other, right? Gary might deploy to dev, then I might deploy over his deployment to dev. So concurrency allows you to say, you know, if a workflow that matches this group ID is already running and you start a second one that matches, that second one waits till the first one finishes. That's all we're doing there. And then we get to the job section. And we have 3 jobs: deploy to dev, deploy to staging, deploy to prod. The jobs are all the same. They do the exact same thing, just with some different parameters, which is why I made this a reusable workflow. The first thing you're going to notice in trying to access a reusable workflow is you fully path to it. Organization, repository, .github folder, .workflows, reusable workflow file name, and then the version. Now, in this example, my reusable workflow exists in my repository, but I could have had it exist in its own repository as well. But what I'm doing here is, and then I'm passing in some things, like I'm telling it, you know, what I want it to run on. I'm specifying the artifact to deploy that it's going to grab from the release so it can actually deploy. I'm specifying an environment, which I haven't talked about yet, but I will, and an environment URL. And then I'm also specifying the app name where I want it to deploy. And in this case, the release number, the release version that I want to deploy, which is the release that just kicked this off. So if I grab this uses statement and I come over here, oh, did not grab it. That's embarrassing. Let's do a copy. And github.com/boom. Not found. Oops. All right, I did something wrong there. Oh, I've changed the name of it. No, I didn't. Let's go. So if we go back to my workflows, in here is my reusable workflow. Publish release with a reusable workflow. There it is. Now, this is the actual reusable workflow that's being called, which is just a workflow file. Nope, that's not it. That's not the reusable workflow. There's the reusable workflow. Now, this is the reusable workflow, which all it is a workflow file. Line 4 is the special sauce. That's what makes it a reusable workflow, by using the event workflow_call. That's what makes it a reusable workflow. I specify my inputs, and then I specify one or more jobs. In this case, I've only got one job, which is deploy web app. So I'm giving it a name, deploy to, and I'm specifying the environment name, which is from the inputs. Here's where I'm specifying what it runs on, which was passed in. But then I have this environment keyword. Now, this environment keyword is how you specify that a job is targeting an environment. And how does a job target an environment? It does that by specifying the environment name. So in this case, I'm passing in the environment name for the first job, which is dev. So I'm targeting the dev environment. So where am I specifying that dev environment? Well, you're specifying that dev environment in the repository settings. So if I go to the repository settings and I go to environments, then you can see I have 3 environments that I've created. I've got a dev environment, I've got a staging environment, and I have a prod environment. And each environment can have different things set in it. Let's look at the prod, because that one's the most interesting. In the prod environment, I can specify reviewers. So this means that if I have a job that targets the prod environment, it won't run until somebody approves it. Or if somebody rejects it, it's going to fail. And I can specify people, I can specify teams for the reviewers. I can also have a wait time. Maybe it has to wait 30 minutes before it can run. I can specify I have to be coming from a certain branch. And then I can have environment level secrets. So these are secrets like passwords, user IDs, whatever I want them to be. That in this case, it's my Azure Client ID and my Azure Subscription ID. But these are secrets that are only available if I am targeting this environment, because these are specific to my dev environment.
So Mickey, relevant to those secrets, we've got a question that if you change the secret, will that secret change trigger a test of the environment where the secret is saved? So if you change a password for production, will production be tested to ensure that that secret will work in the intended environment?
Not automatically, it's not. You could probably build a workflow that might trigger. I'd have to see if that's an event that would trigger a workflow. If it is, then you could create a workflow that would run when you change the secret and see what happens. Otherwise, there are events that get thrown in the audit log, so you might be able to capture that in the audit log and then use that to potentially trigger a workflow. But it's not going to do it by default.
Yeah. So
Yes,
go ahead, Wayne.
Hey, Mickey, one reason why I asked that question is we change passwords all the time, or web certificates. And we've actually had web certificates actually bring down the system where you shut down a whole team for 2 weeks because that certificate doesn't work.
Right.
Or a password doesn't work and they can't get in. And there's nothing worse than getting yelled at 2 o'clock in the morning saying that someone can't get in.
I 100% agree with you. So you definitely should build something like that into it for sure. Sorry, I cut you off, Wayne.
That would be a nice feature to have, so that when we make that secret change, it will actually test the environment.
Well, what is tested? But to test the environment, you basically need to kick off some kind of workflow to verify, to then use the secrets to verify that the secrets are valid.
Correct.
Right. So I'll have to go look. Let me go look and see if there's an event that triggers off of that, because if there is, then we could easily create a workflow to do it.
Anyway, thank you. Sorry for stepping in.
Oh, no, it's all good. It's all good. So I'm targeting my environment, dev, prod, QA, whatever I'm passing in. And then I've got my steps. And my steps are checking out the code. I don't really need to, but I am. I'm logging into Azure via OIDC, and because I'm using OpenID Connect, which I'm running out of time, so I won't dive into, is you only need the client ID, the tenant ID, and the subscription ID. I don't need the client secret. I only need these three things. And that's because on the Azure side, I have specified that using these three things, I can't access my app service unless I'm also coming from this GitHub repository and this specific workflow. So I've locked it down, so to speak. Then I need to download the release, right? We had a release that triggered this. We saw the zip file that was on the release, but I need to download that release so that zip file so I can deploy it. So I'm using the GitHub CLI. If you haven't looked at the GitHub CLI, this GitHub CLI rocks. The GitHub CLI is basically a CLI for GitHub. It works on Windows, Mac OS, or Linux, and you can do almost everything that you can do from the browser, from the command line now. And one of the reasons I like that is because it makes it easy to script things. In this case, I'm actually using it to go to my release and download the zip file. And then finally, I just run an action from the Azure team called Web Apps Deploy that's going to deploy my app out to the appropriate app service. And because I made this a reusable workflow, my actual deployment is a little bit easier to read. And it's because it's the same, it's just calling that reusable workflow and it's the same file, it's just different parameters. Now, if we actually come out here to actions, we can see we're currently in a wait state because we've deployed to dev, we've deployed to QA, and in fact, because we provided a URL, we even have a nice little link here where we can go see if the deployment actually worked. Oh, I've broken something. So you'll have to trust me that the deployment works. That's embarrassing. I have to fix that. But it's waiting for me to approve the deployment to prod. So I can come in here and I can review this deployment. I can say, looks good to me, ship it. I can approve it. That's going to then kick off the deployment to prod. And over here on the code tab, I can even go down to my environments and I can see that I've deployed to dev and staging. I'm currently queued to deploy to prod, and I can go in and see all the different deployments to state to dev that happened, for example, and the code that was deployed. So with using reusable workflows and using one of the options for building a custom action, we have consolidated our code, made our code where we can reuse it, made our code a little bit easier to use. And we've also gone through an actual real world example of a customer I have as this is how they do their deployments. Now, I am out of time. So obviously there's some stuff I did. Well, you tell me if I'm out of time. Gary, how much more time can I have, Gary, if any?
Well, I think everybody's still, as long as everybody's still excited and sticking around, I think you could probably go another 10 or 15 minutes, maybe.
Awesome. That's all I need to be able
to.
Oh, I could, trust me. All right, so give me another 15 minutes. Let's see how far we get. So that was reusable workflows, and that was one version of a composite action, of a custom action called a composite action. So if you'll remember, I told you that in the GitHub Marketplace, I created an action out here to tell a dad joke. There you go, get a dad joke. Now, all this action does is it hits the website Icon has dad joke. This is always scary when you're doing live demos because you don't know the joke that's going to come back, but so far we've been okay. So we're going to keep our fingers crossed and keep going. But I've created an action to tell a dad joke. I've actually created this action 3 different ways, using all the different ways that you can build custom actions. So in this case, this is a composite. This one in the marketplace is simply a composite action. Same as what we saw before with what I did with my build. Now, because it's in the marketplace, it has to exist in a public repository, so I can actually go look and see the code. And if we look at the code that makes this up, there's my running composite. I only have one step. That step does a curl to get the dad joke. Then it uses the outdated format, which this is no longer the way you're supposed to do this, so my apologies, but it uses the outdated format to set an output from this step. And the output from this step is called joke. And the value is going to be whatever I stored in this variable dad joke. And then to output this from the actual action itself, I declare an outputs. I call it dad joke. And I say, go to my step, go to my get dad joke step, which I defined here, go to the outputs from that step and get the joke output. That's it. That's all I'm doing. So I wanted to test this before I used it. So I actually created a workflow file in here that simply calls my dad joke. I set the step ID to be my joke, and then I echo out steps, go to the my joke step, go to the outputs, and output dad-joke, which is the output that I specified in that composite action. So if we come over here to actions, and this is where you keep your fingers crossed, and I run this, then it should only take a second to run, and we can see, if it tells us a joke or not. Composite actions are great. They're easy to build. That's normally where most people start with building actions, because it's just writing a script or putting multiple steps together. Have you heard the one about the film Constipation? You probably haven't, because it's not out yet. That is definitely a dad joke. So, custom action, using a composite custom action. Now I want to build the same thing using C#, because I used to be a C# developer. So to build the same thing using C#, I have to do it using what's called a container action. So the idea behind a container action is you're going to download a container, and then you're going to run your action in that container, which means that, I can use anything I want really to build this action, as long as I can find a container that has what I need. The drawbacks to using a container action are they're slow, and they only run on a Linux machine with Docker installed. So our hosted runners are Linux machines with Docker installed. If you're using self-hosted runners, they have to be Linux machines with Docker installed. So let's go actually kick this off, and then we'll look at what it's doing, because it does take a minute or so for it to run. So we'll run this workflow. And while it's running, let's look at what makes up this action. Well, this looks a little more complex. Every custom action, composite, container, or JavaScript, has to have an action.yaml. So in this case, I'm asking you to input your name, or when you run it, or I'm taking a default value, and then I'm outputting the dad joke. Secret sauce, using Docker, says that this is a container action. Then I specify the image I want to use. In this case, I'm specifying my Docker file, and I specify any arguments I'm going to pass in. In this case, I'm passing in the name that was entered when I use this action. So if we go look at the Docker file just grabs this image. It copies my code onto the image. It copies this entry point.sh shell script onto the image, makes it where I can run it, and then sets that as the entry point so that this shell script will run when once all that's done. Now all this shell script does is a .NET restore, a .NET build, and a .NET run. It's just executing my C# code. And my C# code is here under my app, program.cs, where all I'm doing is making a call to I can as dad joke and getting back the output and getting back the dad joke from them. And then I'm using the wrong way to do this. I apologize if that hasn't been updated, but I'm actually setting the output of my dad joke and outputting and writing out the joke. I'm actually going to output your name and the joke at the same time. So if we come back over here to my actions page, we'll see that this took 43 seconds to run. Compare that to the composite action that took about, I don't know, 6 or 8 seconds to run. Containers are slower. One of the reasons they're slower is they have to download the container. So if I come out here and look, I can see that, it's going to build my container for use, pulls down all the layers, doing all that good container stuff. But ultimately, it gives me a dad joke. What musical instrument is found in the bathroom? A tuba toothpaste. There you go. Another dad joke for you. But I can use the beauty of container actions is I can use any language I want to, which means I can write in a language that I'm comfortable with. They're just going to be slower. You need to be careful when using actions from the marketplace because most actions don't tell you they are a container action. And therefore, if you try to use them on a Windows runner or a Mac runner, they're going to fail. The only way you're going to know they're a container action is going to be to actually go look at the code and see if there's a Docker file, or look at the action.yaml and see if it says Docker. So we've built the same action as a composite action, as a JavaScript action. Well, we got one more way, or a composite action as a C# action. The final way is a JavaScript action. And JavaScript is the most powerful, as long as you know JavaScript, and it's usually can also be the fastest. Again, we start with the action.yaml file, where I'm specifying an input, I'm specifying my output, I'm saying using node 12, or I could have put node 16, I suppose, at this point. And then I just specify the starting point, my index.js. And my index.js is simply JavaScript to go and grab the dad joke and write it into the output variable so that I can use it in other workflows. And again, if I come over here and run this test JavaScript action, then it should run probably in about 15 seconds or less, unless it takes longer than that for us to get a runner. And this one should also come back and give us a dad joke. Why didn't the orange win the race? It ran out of juice. Okay, so I have created the same dad joke 3 different ways, the same action 3 different ways. All of these are in public repos. All of this is all of how you build these actions is also documented in our GitHub docs, but it shows you how you could start, building your own actions if you want to, and even submit them to the marketplace. Now, if I come back over here to my GitHub Actions presentation repository, and I go to issues, there's an issue in here called dad joke issue. You can actually come to this issue if you want to, public repo. But if I go to that issue and I scroll down to the bottom and I say /joke, this is going to run a workflow that uses my joke action to tell a joke and come back and we'll put it in the issue. And this is what while that's waiting for that to run, there you go, it's already done. Here's your dad joke. Skeleton walked into the bar. He said, I need a beer and a mop. Got to think about that one for a second. But I do this demo here because this is a very silly example of issue ops, using issues to drive workflows, to drive things that you want to do. So if I look at what this looks like, I'll go to my workflows folder. then I have tell a dad joke with issues. In this case, I'm watching for an issue comment to be created. I'm calling my dad joke, and then I'm using another action from the marketplace to upload the add another comment to the issue with the dad joke itself. Another example of not CI/CD but using workflows. Even another example of not CI/CD and using workflows is if you go star my repository. Because if you star this repository, it's going to kick off this workflow, which is watching for my repository to be starred, and then we'll randomly change the color of the light bulb behind me. So you can come in, and again, another example of a non-CI/CD use of workflows. Silly example? Yes, still works. I got 5 minutes left that y'all gave me, so I got one more thing I want to show you, and that's caching. So let me see, is caching here or is it in my other? Now, one of the things you're going to find is, and you probably have found this with your other pipeline systems as well, is that, you know, whenever you do a .NET restore or you tell Node to go grab all of the things that it needs from NPM or whatnot, you know, that can take a while to restore all those dependencies. So the idea behind caching is we restore the dependencies, you restore the dependencies once, then you save them somewhere. And the next time you don't run that restore, but instead you grab them from where you save them, put them on the runner, and that will speed up the build process. I had one customer where their build was taking about 25 minutes to run, and we implemented caching, and it dropped their build time to less than 5 minutes. So it can have a dramatic effect. It can have a dramatic effect. Now, I just want to show you that my build without caching takes about 2 minutes to run. So I want to kick off this build, the same build with caching, show you a couple of things. While I'm doing that, let's see what this code looks like. My build with caching. I'm checking out my code. I'm setting up Node because I need it. Then I'm using just an action that was built by the actions team called actions cache. And what I do with this cache is I specify what I want to cache, and I give that cache a key name, which is a name for that cache, so that then I can specify that name in the future and be able to reuse that cache. And that's all this is going to do. It's going to take all the Node modules and store them in the cache. Now that cache is stored in GitHub. It's by default, you get 10 gigabytes of cache per repository. If you go over that 10 gigabytes of cache, then it's going to start deleting the oldest files first. Also, if, what else was I going to say? Yes, also it only lasts for 7 days. So if you haven't touched it in 7 days, it's going to delete the cache. But what you're going to also remember is when you run these things for the first time, it takes a little longer to run it the first time than you expect. And that's because it has to build the cache. So it's not going to be fast the first time you run it. But what we're going to see here in a second is it's going to build the cache. I'm going to show you the cache. We're going to run it again. It's going to run really fast, and then I'm going to be quiet for the rest of the night and let Gary give out prizes, I think. So any questions while we wait for this thing to finish running?
Yeah, I was about to tell my joke, and then somebody asked basically the same question. So you know, the long-standing joke is that there's only 2 problems in computer science: naming, cache invalidation, and off by 1 errors. And one of the questions is what about invalidating the cache if you have a problem with that with the current build?
If you want to invalidate the cache, you can do that. You can delete the cache by doing it manually. But well, 2 ways. If you want to invalidate the cache, you can either delete the cache, and okay, let me try again. If you want to invalidate the cache, okay, this took 2 minutes and 17 seconds. Let's run it again. you could delete the cache, and you can delete the cache either manually through the GUI, or you could actually do it through, say, an API call. So that's what, if your cache is invalid, then you're going to want to whack it, essentially. Now, how do I delete the cache through the GUI? Well, if I come over here to actions, there's the cache that it created. So I've got 200 megabytes of stuff that's cached. And if I needed to get rid of it, I could, simply click the delete button and it would let me get rid of it. But what we're going to see is it now took 36 seconds to run. Without caching, it took almost 2 minutes to run. With caching, it took 36 seconds. Caching is important. If you're restoring a whole bunch of stuff every time you do a build, whether you're using GitHub Actions or some other system, you should be implementing some sort of caching to make it run faster. Now, just real quick, and then I'll answer questions. I do have videos about this and all of the stuff. If you go to, just say shameless self-promotion, but if you go to youtube.com/Mickey Gousset, I got nothing because YouTube won't come up. I got all kind of stuff out there about actions. I love talking about actions. So there you go. All right, Wayne, you had a hand up.
Yeah, Mickey, I saw you had some hard-coded versions of an action, like 3.0.2. Okay. All of a sudden, that's bad. I have a, I didn't delete it or whatever, because it needs still to be out there. Okay. But I don't want that to validate as a usable test. Do we have anything out there that will actually disable versions of code saying is, hey, if you use this version, it's going to fail, because we know that it has some type of, some type of bug that wasn't secure, that a security patch didn't catch?
So not to disable it. If you know you've got a bad version of your action, like say version 3.0.1 is bad, then essentially you remove the tag. If you remove the tag, that tag's no longer there, and when I go and try to hit that, it's going to fail at that point. Now, you do also have the capability using a product that you get for free called Dependabot. Dependabot's a free product inside of GitHub that basically looks at the packages that you're using and will tell you if there's security violations in those packages or newer versions of those packages that are available to you. It does the same for your workflows and your actions that you're using in your workflow.
Great answer. Thank you.
You're welcome. All right, Gary, I'm gonna quit talking.
Excellent. Well, I am going to
I will release screen sharing.